Are you ready? Yes? Are you enthusiastic? Are you motivated? Excited? All right, I am. So, all right, syntax. So now, this is where we are. I have this, it's a little victory here. We have this little check here next to storage because we are done. We have S3, we have Azure Blob Storage, we have HDFS, either flat or with a file hierarchy, either with blocks or without blocks. So now we know how to store data. We know how to store bits, let's say. And we are going to now start looking at what we store in there. And starting with the encoding is going to be very brief, also because you're computer scientists, so many of you know these things. So it's actually a physical thing, right? Computers understand zeros and ones. When we store objects or blocks in HDFS or Azure Blob Storage, they are made of zeros and ones. That's all there is in a block. But when you store CSV, JSON, XML, the syntaxes we are going to look at, this is text. And there is here a small gap in between because you want to store text as zeros and ones. And now it sounds like, okay, that's easy, you just map them. But no, that's not how it happens because historically there were many ways to map them. And then it started with ASCII, which in the very early computers. But then, of course, as the world started adopting computers, we also needed special characters. And then there was plenty of additional conventions, ISO-Latin one, but many others. And then finally, now today, we have very good standards that contain everything like UTF-8, UTF-16, right? So these are encodings that tell you when you have a letter, a character, a digit, a letter, whatever, how do you convert it to bits to store it on in an object or in a block? So this is the very early ASCII table, which you're probably all familiar with or you've already seen. So you can see you have all the uppercase, lowercase letter, the digits, you have the first two rows or columns that are associated with control characters. And then you have a few special characters, right? But now, if you are building new software or a new website or a new database, you should from the very beginning use standards, encoding, so it's called internationalization, make it already from the very beginning forward compatible. So this is why now UTF-8 is a pretty good solution. The idea, you need to think of it in two parts. There is a first part that is a catalog of characters. This is character number 1, this is character number 2, this is character number 3, this is character 1,285,000, like this huge catalog of characters, but there are no bits in there. It's just numbers. You just catalog the characters and assign them an order, a position in your catalog. Who knows what this catalog is called? Unicode, exactly. That catalog is called Unicode. Unicode is not an encoding. It doesn't encode anything. It just tells you this is my catalog with the characters and this is their number. This is called the Unicode code point. And then, based on the Unicode code point, you have standards like UTF-8, UTF-16 that take that Unicode code point and convert it to bits, right? But they can do it in different ways. So this is, for example, in UTF-8, it's elastic. So when it's up to 7 bits, like this example, that's the letter uppercase P, then you just put a 0 and then the code point in base 2, right? If it's up to 11 bits, but more than 7, then you do 2 packets. You start 110, so the 110 tells you it's made of two parts, 2 bytes. And then the second one is a continuation flag that starts with 10, and what is in black is the actual code point in Unicode in base 2. And if it's up to 16 bits, the euro sign, for example, then you'd have the 1110, that basically is a flag that tells you there are 3 bytes, and then the continuation flag 1010, right? And you see it's elastic and it can expand to more bytes. Then you have UTF-16 that has a minimum of 2 bytes, UTF-32 that has a minimum of 32 bits, so that's 4 bytes, right? The Unicode catalog keeps expanding. You see announcements once in a while that they added new characters, but these days it seems to be a lot about emoji and adding new ways to smile and so on and so on. So it's very nice, but basically the catalog keeps going, right? And in fact, this is the reason you can copy paste emoji. It's because of Unicode and because of this character encoding that we are able to do that in our favorite apps. All right. But this is it. This is what I wanted to say on encoding. So basically, we have ways to encode text to bits. And so now I'm just going to talk about text right now. I'm just going to talk about text files, which is why now we are already, it was very quick, one level up in the stack, syntax. So syntax applies to all data shapes. I told you, tables, trees, graphs, cubes, text, which now we use vectors, vector databases for unstructured data. But you can see there are syntaxes for everybody, right? You probably heard of CSV for tables, XML and JSON for trees. For triple stores or graph databases, we have Turtle, we have RDF over XML. These are syntaxes for graphs. For cubes, we have XBRL. I'll talk about it at the end of the course. This I'll also talk about probably in December, right? These two. And of course, text is also a syntax, right? It's just that it's totally unstructured. And now, since it's been 3 years that we actually know what to do with it. But the focus in this lecture is going to be more about the trees. And I will also explain why we are so focused on trees in big data. You will see it has to do with normal forms. Okay. So first, a few words on CSV to emphasize the difference between a syntax and a data model. For CSV, the data model is the relational model. You have a table, right? And in CSV is just text. You can open it in a text editor, and you have, on the first line, you might have headers, comma separated. These are the headers for your columns. And then every line corresponds to one row. And again, you separate all the values with commas, right? So just quick question. If I didn't show you the lower part there, I don't know how I can hide it, but if I only show you this, if you just open a CSV file in a text editor, who sees a table? Right? A lot of you. Very good. So indeed, this is the syntax for trees. CSV sounds like it's super simple and not even worth talking about. You would be wrong about that because even though there is a standard, there are so many ways to deviate from the standard. For example, some people use commas, some people use semicolons, some people use tabs, some people use spaces. So you can change the character that you use to separate the values, right? Then what happens if you have this character, but not as a separator, but as part of a value? Then you need to use quotes, right? So then you need to specify which quote, simple, double, and so on. But the problem if we have quotes is what do we do with quote symbols within the quotes, right? So then you double them. And so you see how it's actually complex. It's actually more complex than it seems, right? And this is why if you did machine learning or data analysis, you probably saw these libraries where you can just open a CSV file, but the first thing you need to do is the paperwork. What is the separator symbol? What is the escape for the quotes and so on and so on? Who's already done that? Been through that? Many of you, right? And this is because there is a standard, but not everybody follows it exactly, right? Maybe one day, everybody will stick to the same CSV standards. But anyway, I'm just checking the time. It's almost the break. I think I should keep that for after the break because otherwise it would interrupt me in the middle. So we are going to take a break. We have ETH juniors with us today. So it's small presentations during the break if you're interested in what they are doing. You want to plug your computer?